Go.
Okay, for question 4a, to find the to approximate r double prime 8.5, it tells you to take the difference quotient between r prime of 10 and r prime of 7, which is this here, and then kind of simplified, just plug in the values of r prime of 10 and r prime of 7, and then don't simplify that anymore because you don't have to. And then remember the units, because it's double prime, it's centimeters per day, and then per day again. And then for B, hopefully you can tell that you need to use the intermediate value theorem. So what you do is you set it up beforehand, saying that r prime is continuous because r is twice differentiable, and then say that -6 is between r prime of 0 and r prime of 3, which is, and r prime of 0 is -6.1 and r prime of 3 is -5. And then you can just write it out because of the intermediate value theorem. Then there must be a t such that r prime of t is between, there must be a t between 0 and 3 such that r prime of t is equal to -6. And then for C, pretty simple, just approximate it and then just have the base between each subinterval times the rightmost value, and then do that 4 times for each subinterval from like 0 to 3, 3 to 7, and 7 to 10. And then you don't need to simplify this as well. And then for D, it's just related rates. You just take the derivative of the volume function and you use chain rule and product rule to get this equation right here, because, and you use chain rule because r is a function of t, so you have to use that. And then they give you all the values for the radius, the rate of change of the radius, the height, and the rate of change of the height. So you just plug it all in, don't simplify it, and then just remember to add the units like they ask, which is cubic centimeters per day.